Hello, everyone, and welcome to our workshop Building Strong Number Sense with the Singapore Math Method and the Use of Manipulatives for grades 1 through 3rd. Today, we are going to explore why Singapore Math approach is so effective and how manipulatives support deep understanding and how can we apply these strategies in our classrooms using simple, easy, accessible materials. By the end of this workshop, you'll walk away with practical techniques you can use tomorrow, as well as confidence in supporting students' conceptual understanding. The Singapore Math Method is built on three key ideas: CPA approach, concrete, pictorial, abstract. Students first learn using hands on objects, then draw or visualize, and finally use math symbols. Number sense before procedures instead of memorizing rules, students understand how numbers work and relate to each other. Model drawing or bar modeling, students learn to represent word problems visually. In grades 1 to 3, the CPA approach is especially important. Students are still developing foundational number sense, and manipulatives play a major role in making math meaningful. Manipulatives are physical objects that help students understand math concepts through hands on experiences. Using manipulatives helps students see numbers as quantities, not as symbols, develop problem solving strategies, build mental models they can recall later, reduce math anxiety by making learning playful and concrete. Research consistently shows that manipulatives help young learners move from concrete understanding into pictorial and abstract reasoning. Here are common manipulatives used in Singapore math classrooms and simple alternatives you can use if you don't have access to standard materials. Based on blocks are used for place value, regrouping, addition, and subtraction. Some alternatives are straws bundled into tens, popsicle sticks, or Lego bricks, like first towers of tens. Develop place value understanding helps students see how ones, tens, and hundreds are related. Based on blocks build numbers concretely and allow students to physically compose and decompose numbers, support addition and subtraction, model regrouping in a meaningful way. They can visualize magnitude and comparison and help students compare numbers like greater than and less than equal to by seeing size and quantity. Based-on blocks bridge to standard algorithms, provide a concrete foundation before moving to written procedures, and they support the CPA approach, serving as the concrete stage before drawing base 10 representations and writing equations. They strengthen number sense and reinforce how numbers are structured, not just memorized. Linking cubes are used for counting, comparison, and building number bonds. Some alternatives are bottle caps, small erasers, and beads and pipe cleaners. Linking cubes are ideal for the concrete stage of CPA approach. They support number sense, subitizing part-whole understanding, counting strategies, early addition and subtraction, comparing quantities, patterning, and sequencing. They are hands-on, visual, and flexible, which is exactly what Singapore Math emphasizes. 10 frames are used for making 10 addition, subtraction, and early multiplication. Some alternatives are drawn grids on paper, egg cartons cut into 10 cups, or muffin tins. 10 frames help children to see numbers instead of counting them. They help recognize patterns, understanding part-whole relationship, build mental math strategies like making 10 or and counting on, connect concrete pictorial abstract thinking. They are one of the best pictorial models in the Singapore sequence. Pattern blocks are used for geometry, fractions, and spatial reasoning. Some alternatives are printed shapes on cardstock, foam or cardboard cutouts, and tangram sets. Pattern blocks help students see relationship between shapes, composed and decomposed holes, build early number bonds using shapes, recognizing fractions, learning sides, corners, and size, develop visual spatial reasoning, build problem solving stamina. Singapore Math emphasizes these foundational skills in the early years that they teach. Counters are used for grouping, skip counting, and solving in arrays. Some alternatives are beans, buttons, coins, and small toys like mini animals. Number lines are used for sequencing, arithmetic, and skip counting. Some alternatives are masking tape line on the floor. You can draw your number lines or use rulers. Number lines develop number sense and magnitude, help students understand where numbers are located relatively to one another. Support counting forward and backward, reinforcing counting on and counting back strategies. Model addition and subtraction. Show addition as moving forward and subtraction as moving backward. Build understanding and comparison. Visually demonstrate greater than, less than, and equal to. Support mental math strategies like encouraging jump skits and chunking instead of counting by ones only. Introduce early concepts of distance and difference, help students see subtraction as the distance between numbers. Bridge to abstract thinking. These serve as pictorial representation between manipulatives and equations. Support problem solving. This helps students represent and explain their thinking clearly. Bar models are used for visualizing word problems. Some alternatives are paper cut into strips, sticky notes, and graph paper. Visualize part-whole relationships help students see how quantities relate to each other within a whole. Support addition and subtraction problem solving, representing joining and separating and comparison situations clearly. Model comparison problems like showing how much more and how much less visually. Support multi step thinking, helps students organize information in word problems. Bridge concrete and abstract thinking, serving as pictorial step between manipulatives and equations. And clarify problem structure, helping students focus on relationship, not just numbers. This builds confidence with word problems, providing a consistent strategy for solving word problems. Lay the foundation for later algebraic thinking and introducing unknowns as visual in an accessible way.
Today we're going to bar model a question requested
This
from the
TikTok
comments. The question is, I ate 6 cookies. I
doctoral
ate 19 more cakes than cookies. How many sweets
is
today?
a
This is a
doctoral
two-step
student
word
in
problem with 4
mathematics,
prompts.
born
So we
and
want to
raised in
use bar modeling to
Singapore,
help students in the
and
problem solving
is an
process.
expert
As
in the
always, let's
Singapore
bar model
math
along with the problem. We're going to
methodology.
start with a box
Let's
to
watch the
represent the 6
video
cookies and label
for
it cookies. Then the problem
regarding the
says, I
bar
ate
models
19 more
and
cakes than
how
cookies.
this
Okay, so
helpful
which one did I
strategy
eat more?
is.
Cakes or cookies? Cakes, that's right. So should the bar for cakes be longer or shorter than cookies? Longer, perfect. So we'll draw a longer bar here for cakes and label it cakes. When students are working on problems like these, they should be very familiar and comfortable with the structure of the comparison model already. If they are not, it may be a good idea to review one-step comparison problems with them. So at this point, students should be able to tell you that this part of the cake bar is the 19 more and this part here will be 6. Now, the problem is asking for how many sweets did I eat in total. So the question mark will go here because we're trying to find the total of these two bars. This is when we need to spend some time mapping the comparison model to the part-whole concept. And a good way to do this is to bring back our number bonds. Because we're trying to find the total, which is the whole, we actually need to figure out the two parts. And in this problem, the two parts are the cookies and the cakes. This is also where the reasoning starts to happen. So, okay, we know that the quantity for cookies is 6. Does the problem tell us the quantity of the cakes? No, it doesn't. But can we find that out? Yes, we can. Based on our model, we can find out the number of cakes by adding 6 and 19. I make this equation a non-negotiable for my students. They have to write out the equation and label what this equation is for. This helps them build up their problem-solving framework. Now, do we have both parts to find the whole? Yes, we do. Okay, so what's our next equation? It should be about finding the total, which is 6 plus 25, giving us 31. Finally, don't forget to answer the question. I ate 31 sweets in total. I'm your Singapore math expert from Singapore, helping you navigate your Singapore math journey. Today we're going to bar model a question requested from the comments. The question is, I ate 6 cookies. I ate 19 more cakes than cookies. How many sweets did I eat? This is a two-step word problem with no prompts, so we want to use bar modeling to help students with the problem-solving process. As always, let's bar model along with a problem. We're going to start with a box to represent the 6 cookies and label it cookies. Then the
Look
problem
and
says,
follow
I ate
her.
19.
Now let's walk through an example of how we teach addition using the CPA approach. Using base 10 blocks, students build the number 47 and the number 35, and they combine the ones, regrouping if needed, and then combine the tens. And here we are doing the regrouping. 45 plus 35 equals 82. Students draw tens in the pictorial stage and ones and use number bonds diagram to show how numbers break apart and recombine. We're not going to use the manipulative here. They are going to draw the tens and the ones. And students draw tens and ones or use a number bond diagram to show how numbers break apart and recombine. And in the abstract stage, students will solve using vertical addition and or mental math strategies such as making tens, while driving them into the concrete, pictorial, and abstract stage to solve the equation. Let's say Maria has 26 stickers and she gets 18 more. How many does she has now? In the concrete area, students use counters. In the pictorial, they can draw a bar model showing the part plus the part and a whole. And in the abstract, they will go straight to the equation. That's how we will solve a word problem using bar graphs. To get the most from manipulatives, here are the best practices. Always start with hands-on experiences before worksheets. Let students explore manipulatives freely before using them academically. Ask guiding questions. How do you know? Can you show it in a different way? What happens if we regroup? Encourage collaboration so students verbalize their thinking. Gradually reduce reliance on manipulatives. Do not remove them too early. Manipulatives are not extras, they are essential tools that help students build real mathematical understanding. The Singapore math approach, especially the CPA method, empowers children to think deeply, reason logically, and approach math with confidence. Thank you for joining this workshop, and I hope these strategies help you strengthen your math instructions. Please complete the short quiz to demonstrate your understanding. This form helps verify your attendance and confirms you watched the full session and gives me feedback so I can keep improving this training. It only takes about 3 to 5 minutes to complete. Once you finish the form, you're officially done with today's workshop. Please make sure to submit it before you leave or by the end of the day. If you have any trouble accessing the form, just let me know and I'll assist you. Go ahead and click the link now and you may begin. Thank you. Here are the references used for this workshop, and thank you so much and enjoy these strategies in your classroom.